All right, I'm going to be going through the configuration for the deployments, and my deployment is already running. Like if I say, if I try to, all right, so my deployment is running pretty well. All right, so I'll be going through the deployment and going through the different sections. All right, so I have the deployment for my for Postgres and then for my Django backend. All right, so let's get to it. Now, if I uncollapse this, it may look like a long file, but actually it's divided into sections that are pretty much standard and that can be related with. So I'll just collapse the sections. Perfect. So right, so we have, of course, we specify the API version and the kind. So this is the kind of object that we are creating. So if it's a service, we put a service. If it's a pod, we put a pod. If it's a deployment, we put a deployment. And I installed something that allows me to see like the documentation. Uh, what was that? Kubernetes. Uh, all right. Uh, Kubernetes are templates. Yes. So Kubernetes templates allows me to like quickly, create quickly create a file. So for example, if I come here and I say deployment, it already will show me like different like the templates. So I K8 deployment, kube.deploy, that is all the same thing. So if I choose this, it's showing errors because so if I choose this, you see it like brings a template which then I can easily fill out if I know what the meaning of this, if I know what I'm doing. Yeah, so I don't really have to write everything. So even for a service, I can just say service and boom. This 3 lines is a separator showing that I am beginning a different document. So for example, if you see my file, I have a deployment, then I have a service, but literally I could put these into different files. But if I use this, three dashes separator, it indicates the beginning of a new document, so I can put multiple documents in one file. So even for a service, you see it brings me a template that I can really fill out and then remove the parts that I don't really want to work with. So that's how I like created this file. All right, so so the three parts that we have are, so we have this metadata. So for everyone you create, you'll have an API version and then kind. So now the sections that we have the metadata section, we have the specifications section, and then we have the status section. Status. But the status section is not indicated here. But when we deploy this deployment, when we apply this deployment, that status will automatically be created and it keeps, the current status, and our definition and the current status should always match. So it always compares them, the status and what we deployed. And if there is a difference, then it will changes will be made. So let's see. So this metadata it holds, the metadata for our deployment or whatever object we have. If it's a service, it will be the metadata for that service. So metadata could have a number of things like name, namespace, labels, basically metadata that applies to that particular object. So in this case, we have like the name of this deployment. So this is the name. It belongs to the namespace. We putting it to a default namespace, and this is so if we don't specify a namespace, it will be the default one, but I just decided to leave it there so that we can see it. But this, we could really name it something different, and every object that we create that we want to put under that namespace, then we indicate the namespace. Yeah. All right, so as you can see, my deployment and my service are in the same namespace. So then the label, this label I'm now labeling my deployment. So if I want to like if I have multiple deployments and I want to get those the deployment by label, then this will be helpful. So now, this specification is the specification for the deployment. Like now, this is what defines what our deployment should be, or what we want our deployment to look like. So, for example, we have a selector, which basically tells us that we want this deployment, to be we are saying that whatever configuration we are putting under the specification belongs to this deployment. So that's why we are now putting a selector to select based on this label. So this means that what we this specification will belong to this deployment, since we have put a label, selected, use the selector to select that same label. We have replicas. This will tell us like how many replicas to create. So if we are going to create once this is creating the pods, if we put like 3, it will create like 3 pods in the replica set. Yeah, if we put 1, it will create 1, and we will see that practically a bit later when we apply this deployment. There is like strategy. I want to talk more about this strategy, but this has to do with it has to do with how the pods are replaced when they fail or when they die. It has to do with how they are replaced. And if we try to see this max surge, it's the maximum number of pods that can be scheduled above the desired number of pods. Yeah, so this is the strategy, but this is not really, this is optional, it's not mandatory. Now we have a template. Now, these templates are, it is what we define under here within this template. Now we are, specifying, we are now, this is for our pod, basically the pods. So this is, the above specification was for the deployment. This is a deployment spec. And once we enter this template section, this is now a pod template specification. So this is, we have a pod specification inside of a deployment specification, and this is what tells how our pods will be, how our pods will be created and what they will be made of. So again, we are saying that this, we are specifying like metadata for our pod, and we are also giving it a label. So we are giving it this label, and whenever we are looking for pods or trying to attach, when a service when we are looking for pods, we can always look for them using labels. Yeah. So it is part of metadata for the pod. And now we have so basically you see that this pod definition or configuration also has metadata and specification. Yeah, the same way this the deployment the deployment configuration also had metadata and specification. Only that this is inside of it's like this pod configuration is inside of the deployment configuration. So for the specification, this is where now we specify how we want our pod to be. So for containers, the container name will be this. The image, the container will be created from this image. And since this is an image we build locally, I have like a Docker file. So I ensure that I first build this Docker file such that this image will be available. I build this Docker file with the same image name that I am putting here, and so that it will be available. Image pool policy. This is if if we can say if image pool policy is always, then it will mean that uh, you know, it will always attempt to pull the image from the Docker repository, from the Docker registry. But now I'm saying on a pull if not present. So it means that it will always use the image found locally, and only will it try to pull if the image is not available locally. And then this is the command we want to run on our container once our container is created. Now, these are environmental variables that we will want to make available within our container. So we want our container to have these variables: Postgres user, password, and host. And so with these variables, um, now that we have specified them within the pod specification, they will be available within the container that is created. So for example, if I'm to show you, so these environmental variables are set. I will just use, like, for example, this one. If we go in our settings.py, since this is the image, if since this our Docker file creates an image from this code base, it means that this is basically what will be running on our container. So if you see, for example, on the um, on the on the allowed on the allowed hosts, you see that we are getting allowed hosts from the environment. We are getting it, the value from the environment. And basically this Django allowed hosts, what we are setting here is what we are getting here. Yeah. And if we wanted, we could actually also come and get the these from for example, I can also get these from the environment, if I wanted. So I could, since I've set them here, I could basically come and say I could basically come and say get this, get env, oh sorry, I could basically come and get, what was that? That was the name. So I could, did I specify the database name? No. Let me do that for the user. Okay, so I could actually say os.get environmental variable. So, oh, sorry. So I could now. So now this now will be picked from my from the environment, from the environmental variable that is set here. Yeah. So um, That's it mainly. And then we have the ports. So this port, container port, this is the port that will be exposed by our container. So if you try to see here, we are running the command and we are, you know, running it on port. We are running the server on port 900, and we want to expose that port such that this can be picked, the output can be picked, yeah. So by our service later on. So the container port that we are putting here is what is exposed by the container when the container is created, yeah. And we are saying the name is this. This is basically the name of our container. So the restart policy always, this means like if our pod gets any problem, it will always be restarted, yeah. Or if it faces any error or container, the container will always be restarted, yeah. So this is basically it. So same thing with the service, API version kinda, then metadata, and then the specification, same stuff. But what we see here is that these ports, so this port is a port that will be exposed by this service. Then the target port is the port. Remember, this service sends traffic uh, to the container, or to the pod. So the port that we are exposing is the target port that we are having here, because this service will be targeting and sending its traffic to the container. So the target port will be the port that is exposed, yeah, on that container. So this is what it basically is. So if we put, let's say 10,000 here, or another port like 9090, it means that it will try to target that port on the container, and it will find when it's not exposed, because we have exposed, we are running this and exposing a different port. And so if we try to do this, the target port will be what we are not exposing, and then that won't work basically, yeah. All right, so the same thing with what is going on here in our Postgres deployment are a secret. So we are creating a secret. This kind, the secret holds secret data of uh, any type. So it also has metadata, and then the type. This has to do with how we are handling the secret data, and then this is the data that we want to add to our secret, yeah. So when we are accessing this data later, we will pick it from the secret, yeah. And because we are putting it here, we are giving it through a secret. When the deployment is applied, if someone tries to check the configuration on the server, they won't, for example, see the username and password. It will just indicate that this is coming from a secret. So that kind of makes it safer. Yeah. Yeah. So we have this object called oh, oh, I don't know what editing. Okay. All right. So on the deep, all right. So we have a persistent volume. So basically, a persistent volume is a storage resource provisioned by an administrator. So volumes are good good for persisting data, because basically when our containers stop and start, they lose all the data. So but if we have volumes, then our data can be can always be persisted there. So we're doing that using the persistent volume claim. So but it takes the same kind of approach, section metadata and the specification, and of course these what we are defining here is now specific to persistent volume, and here this is specific persistent volume claim. In case any of this, I would, let's say, spend a lot of time going through each of these, but the documentation is all there. So if because of my Kubernetes templates I installed, uh, this is, it's all given if I double click, so no need to worry. So the deployment takes the same structure, metadata specification for the deployment, and then the inner one for the container or the pod, also has metadata and spec, and then same thing, defining it, only that here the image, we are using a standard image. This is pulled from our Docker registry. We have the environmental variables. So what we note here is that this container is exposing port 5432, because this is a default port for Postgres, so we want to expose this port. And if we come to our service, we see that the target port, the service will be targeting the port on this container, will be targeting this port, but the service is also exposing the same port. Yeah, so this now allows us, for example, to in our application, and again, like our services, once they expose ports, it means that anything within the cluster or any container within the cluster can send traffic. A service can send traffic to another service, or containers can send traffic to service. Within the cluster, that communication happens. So that's why, for example, here within our settings.py, the host is the Postgres service, which we are basically defining here. And the port is port 5432. This is the port exposed by the service. So when we hit this service, the service will also try to hit the container on this port. It will also try to hit the container on this port, yeah, because this service is defined, and it is uh, it is it is it is for this this service will be connecting on sending traffic to this container, and it knows that it will be sending to this because we have used the selector to tell it where it will be sending its traffic. Yeah, so that's mainly it. So if I try and run this, I will try and run this. This is actually already running. So if I say kubectl and deployment, so we see it's there. If we say kubectl get service, we see it's all there. And kubectl, I can actually decide and delete everything here and redeploy it. So I can say but I think I won't really go into that, since this video is mainly about showing us how to the structure of the YAML. But anyway, but let's see. Let me just delete them and recreate. So kubectl get deployment. So I'll say kubectl get pod. Perfect. So what I want to do is, whenever we create a pod, a deployment, it also creates the pod. So this is what I'm going to do. I'm going to delete all the deployments and then recreate them. So each of these this deployment has one pod, and this one has one pod because we basically specified, one, uh, one pod on the replicas. So let me delete it. So kubectl delete deployment. All right, so I will delete this graphene deployment. Deleted. So if I try to get the deployment again, I now have one. Let me also delete this kubectl get deployment, delete deployment. Perfect. So if I try to get the deployment, and by the way, I can also see this through minikube. Let me also kill this. Here I had minikube tunnel, which basically allows me to use the load balancer type. So I can also decide to use the minikube dashboard to see what's going on. So you can see my deployments have been deleted. I no longer have any pods. So even when I come here and I say kubectl get pod, boom, there is nothing. And notice something here that everything that is, the pods, deployments is in the default namespace. So for example, if we choose another namespace like kubi system, you'll see the other deployments that are specific to that namespace, Kube dashboard. So that's why it is important to specify the namespace if you have multiple namespaces. But so happens that in our default, this is what we have. Yeah. So for example, if I created another application and I wanted to create uh, other deployments specific to that application and all that, would be nice to create like a namespace for my application and maybe fed HR. If I get another, let's say, an inventory management system, and I want to things of not to confuse the deployments and all that, I could actually put them in their own namespace. Yeah. So our services we still have. So let me delete the service. I can actually even delete from here. So let's see, kubi so ctl get service. So our this service, graphene service, I'm going to delete it. So kubectl get delete service. Boom. So what happens is you will see this one disappear. Perfect. So I can also actually delete it. So now let's say, what service am I left with? Get service, Postgres service. So I can also actually delete it from here if I wanted. Boom. And if I now try to check, it's not there. This is a default service. It comes with it's default, so I didn't create that. These let me just secrets, persistent volume claims. I could also actually say get secret. I've already deleted it, so it won't be there. This is a default one. I can also say get percent volume, so I can also delete this. So that will be deleted. So if I come to persistent volumes, now there will be nothing. This should go actually. This should go, this should go, this should go. So I will also delete this. So I'm really trying to delete them so that I can create everything afresh. So as I talk, we have nothing now. Let me check. I have my image. So everything are all the deployment services secrets, persistent volume claims, and um, I've deleted everything. So the only thing we have is so we actually now don't have pods. Our containers are gone. So that's it. So if I try to say Docker image ls, oh, by the way, if I say Docker images, since I have Minikube, basically there is a Docker service inside of the node, each node that is created within Kubernetes. So within my Minikube node, um, I have um, I have a Docker service. I have, a container service, a container runtime there. So, but then there is also the container runtime. I have also Docker on my physical machine. Then there is the one that is inside of Minikube. Yeah. So, um, here, what I'm mainly interested in is, so if I say images, you see I don't have any images, but I can actually use, try to check the one in Minikube, Docker environment. So if I execute this command again, so this shows that, oh no, I'm running the wrong command. Perfect. Yeah, but this allows me to see images within my cluster. Yeah, so like I said, each node um, has a container runtime, and allows us to you know to have Docker images and then Docker containers. So I also want to delete this so that I can recreate it. Let me first see if there are any running. And by the way, you can see that there is no container that is running. These are the ones, these are not specific to application. You can see these are like, this is for the dashboard, this is for the, so which means that since our pods were deleted, we also don't have running containers within our cluster right now. So I want to delete the image and recreate it. So I will delete this, kubectl delete. No, I can just use Docker image, remove that. But I have to be careful when I'm using this command. I have to make sure that I have used the other eval this so that I am within Minikube, not on my localhost here. All right, so perfect. So as I talk right now, we don't have anything. Even my thing that was running, it should be off. Boom. So now, what I'm going to do is I'm going to to make this one have two replica sets, replicas, and uh, this one will also have this one. Let me create three. Perfect. So let me start by building an image here so that it will already be available when I run this deployment that requires it. Yeah. All right. So so I will say Docker build tag. I All right. I want to make it the same image because I'm referencing it here. So if I make it different, then it won't be found. Boom. So I Docker build. Okay. Yeah. So I have to specify because I'm building an image from a Dockerfile, I have to specify where the Dockerfile is to be found. So the Dockerfile will be found here. So it is in my working directory. So let's run that. All right, so that finished. So if we are to check now, Docker image ls, our image is back, and we see that it was created a minute ago. Um, all right, so now that we have our image, I basically want to first build this Postgres deployment. Uh, yeah, since our since our backend deployment is kind of dependent on it somewhat, uh, it's using it, so I will now apply this kubectl apply -t or so -f. So I am on to, it's called Postgres. um, so when I apply that, uh, let's check within. Okay, so now if I'm to check kubectl get deployment, boom, we have this deployment created, and it is showing that we have 3 replicas out of 3 have been created. Yeah, so if we try to get pod, there should be 3 pods all belonging to created by this deployment. If we try to get service, we should have this one service, and we see that it is basically of cluster type IP, because that's a default type if we don't create specify it, and you know that shows that this service is only accessible within the cluster. Yeah, so you see it's exposing port 453 2. This is the port that we specified, so all good here. All right, and by the way, if we check our dashboard, we should also see that we have deployment there, Postgres. So all good, looking good. So we have 1 deployment, we have 3 pods, and replica set. We have 1 replica set here that has 3 pods. Yeah. So if we see in there, this replica set has 3 pods, and that is the case because we specified 3, you know, replicas. And each of these pods, by the way, has same configuration, same everything, in that if when we are sending traffic, traffic can go to any of the pods. Yeah. So yeah. So perfect. So I will now also go ahead and create the deployment, apply the deployment for for our backend. Boom. So what we should see here, we should see this deployment also coming up. Boom, it's here, and it has created 2 pods, and now we have a total of 5 pods, and replica. This one has this is a replica set. So a replica set basically uh, is what has our replicas. Yeah. So when you open this, we see that we have our pods there. All right, perfect. So if we see our services, so we have this service and this service. This seems to be in pending state, and we can always check. It is in pending state. All right, so let's see. Now we want to be able to access our our service here. So let me see. Kubectl get service. So I should have 2 services. This is the default one. So um you know, the status. Oh, external IP is pending here, and here we have none, since this is a cluster IP, or this is a load balancer, and locally we don't have a load balancer, so that's why the external IP is pending here. So everything is fine, it's only that the external IP is pending. So if we are to check out the URL for accessing our service, Minikube service, because this is the one we should be accessing. Right, perfect. So what we see is that this IP address that is exposed, when we try to access our service, we see that within our deployment, we said that we should access this. We are exposing port 8000, and you know th- we are exposing port 1000, and it is the port here. But on accessing, or when we try to access our service, we see that it is using a different IP address. So this is because basically, if we look at uh, this diagram that shows a full picture of the cluster and the services, so we see that basically within the cluster we have these services, and then we have a node, and then the node has pods inside it. So but what we see is that the service sends traffic to the node. So and then once it sends traffic to the node, of course the node has the pods, and we know the pods that will be targeting on those pods, and that's cool. So this that we are accessing here is the IP address of the of the of the node, and the port that it exposes is this. Yeah, so there is usually a range, 3000 to, it exposes 30,000 to, I think, 30,267, 32,000, oh, some figure like that. Yeah, so we didn't really assign this port, but it just picked, the node picked from the range, and has a port. So if we are to check all good here. So if we are to check kubectl get uh, okay, node. So if we are to describe this, kubectl describe node minikube. So if we are to describe the node, what we see is that it should show us its IP. Yes, we see that the its internal IP is this, and let me see if it shows us the port. Where are you? I can't seem to see it here, but when you try to get our service, we see this port here at 390. This one here. This is the port on which traffic. This is a node port basically on which the traffic from the service, goes to. Yeah, so this is how we know this port. So if we are to check this port, we see it is the same. Yeah, but what if we want to access our service using an external IP? So which will now not be, according to our diagram here, which will now not be the IP and port of the node, but the IP and port of the service. And the port that we exposed on the service is basically 8,000. So what we are lacking is an external IP. So the reason for this is because we are using a load balancer and we don't have a load balancer locally here. But we can Minikube allows a way to for that, for the load balancer, through using Minikube tunnel. So if we do that, perfect. So it is set up. So you see we have a route, going to the node. So basically, now our service, can use a load balancer. So if we come back here and we say get service, and boom, we see that we now have an external service. We have an external IP. Okay, we have an external IP. So we now can comfortably use this IP. So if I come back and try to get service, okay, if I say minikube service dot graphene, boom. Okay, that still opens that. But if I wanted, I can take this IP and put it here and put port 8000, and it should also work fine right now. Perfect, this works well. And also if I come here within my deployments, or my services, so I can see I'm being shown external endpoints. So if I click that, it should also take me to that. All right. One last thing I'd forgotten. We want to see, when we apply our deployment, when it is applied, remember we talked about the third element of, okay, from like our after specifying metadata specification and then status, which we said is created automatically. So if, for example, we are going to see get our deployment, so let's first get our deployment. We want to see, for example, for this deployment, we want to see how it was applied to the cluster. So get deployment. So when we put our YAML, it will give us the configuration as it is applied on the cluster. Yeah. So as we can see, API version, kind deployment, metadata, the specification. Though there are some like attributes added, but also what we indicated is there are replicas. Some of these are defaults that are added for us. Creation timestamp and all that. But what we see is this section called status. Yeah, so what this shows is available replicas 2. So 2 is what we specified within our deployment spec. Last transition time, blah blah blah, da 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 dum. So it has this information, and it keeps comparing, of course, with the added defaults, but it keeps comparing with the deployment we created. So if, for example, on the replicas, it finds the status is 1, and then what we had put earlier in our deployment was 2, it will now try to actually make it 2 again. So um, it will try to make sure that the status matches. It will, let's say, try to create another replica and make sure that the status matches, what was deployed. So we can actually, if we want to see it well, send this to like a file, fedhr deploy, maybe applied deployment.yaml. So this is sent here. So if we try to see, so for example, if we wanted to create a deployment file from our applied config, we could take this and like clean it up and have our, like, if we removed this and blah blah, so we can actually go back to, if I compared this with our actual config, we see that some like information was added on metadata. All our info is there, but there are added things there. We have that, uh, you know so, but when you check the status section, which we practically didn't have, it shows some information like available replicas, all this stuff. Yeah. So this is it about how the status is updated when it doesn't match our applied config. Yeah. All right. All right. So that's it. So before I leave, let me try to log in here. Admin. All right, that works fine. And by the way, if we wanted to enter like our container, we can do it. Uh, let me get our pod, get pod. So let's say we want to enter this you know the container inside this pod. Basically, once we enter the pod, we've entered the container, um, unless there are like two containers, and then we have to be like specific but about which container, but which in any case will be added to the config, so that the deployment will already know which container to target. But if I wanted to, let's say, enter that container and execute some commands, I could say kubectl exec interactive, then I say I want to enter that, and then yeah. So now I'm in the bash of my container. So I can, for example, do a number of things. If, for example, I wanted to run migrations, I can run migrations if I want. Migrate. There is nothing to migrate, so all good. So if I wanted to do that, that should also be fine. Yeah. All right, that's it. Maybe before I go, let me just delete this. I don't need it. One may be wondering why we have lines here. So this is because there is something like one or more containers do not have resource limits. So they wanted me to add resource limits. So if I basically uncomment these resource limits, now my file looks good. But I faced some issue with these resource limits. I think there's something that needs to be put with carefulness. So I decided to comment it out and let it be for now. All right. Thank you so much. Catch you next time in another one.